Okay, for section 2.2, we want to look at something a little bit different, but it uses an algebraic skill that we actually did in chapter 1. So if nothing else, it'll give us practice on some of the algebra we're supposed to know, and we'll at least see a use for it. And we essentially want to look at things like this. X squared plus y squared equals, well, for the sake of argument, we'll say 25. By definition, when you have something that looks like that, x squared plus y squared equals some number, then this is the equation of a circle whose center is at the origin, 0, 0, and then the radius is equal to 5. You take this constant and square root it. So if I had the equation x squared plus y squared equals 49, that would be a circle centered at the origin, 0, 0. The radius would be the square root of 49, 7. Once you understand that, there's really not much you can do with this. So we're going to take our circles and move them around a little bit. Meaning, I'm going to write the formula your book has, but then we'll explain it. And the actual formula for a circle in what's called center radius form is x minus h squared plus y minus k squared equal to r squared. When it looks like that, then the center of your circle is at the point hk, and your radius is just equal to r. Whatever this constant is on the side here, it's equal to r squared, so square root it to get your radius. The one trick to recognize, these negatives are part of your equation, so when you're finding the center, whatever values you have in here, flip the signs of them. So as an example, if we have x minus 3 squared plus y plus 4 squared equals 16, the center would be at the point, that's x minus 3, flip the sign, it's positive 3. That's y plus 4, flip the sign, it's negative 4. There's my center. The radius, take that constant and square root it. Square root of 16 is 4. And there we go. When circles are in this form, once you recognize the form, x minus h squared plus y minus k squared equals r squared, they're pretty straightforward and pretty easy. You could actually graph this one pretty easily. Find the point 3, negative 4, and then go up 4, down 4, left 4, and right 4. You'd have 4 points, and you could sketch your circle. You will be doing some of that for homework, so you'll get a little bit of practice with it. But now we actually want to focus on some algebra. And this is the stuff that we've done before that we're actually going to use again. There is another form for the equation of a circle called standard form that looks something like this. X squared, the terminology of the book, ax squared plus bx plus cy squared plus dy plus e equals 0. Which admittedly looks a little bit weird because all the a, b, c, d, e, a and the x squared and the y's and all that. Don't get confused in what the algebra looks like. Essentially it means you have something like this. X squared plus 6x plus y squared plus 4y plus 2 equals 0. That's the equation of a circle in standard form. The problem is, ultimately, if we care about circles, we care about graphing them to see what's going on, and you can't tell what the center and radius of that circle are, so we have to find a way to do that. And in order to do that, we get to do some algebra that we did before, completing the square. So as a form of review, we're going to put this in center radius form, just so we can practice completing the square because we need it. So if you remember from completing the square, we need to group the quadratic and linear terms together for both the x's and the y's this time. This 2, a constant, has to get sent to the other side. So, x squared plus 6x plus y squared plus 4y equals negative 2. Now, to complete the square, the quadratic terms have to have a coefficient of 1, X squared does and y squared does, so we're fine. We don't have to factor anything out. Now, to complete the square, if you remember, look at the linear term, cut it in half. Half of 6 is 3. Square that, you get 9. You add that on. But the rule is, whatever you add on the left, you have to add on the right to keep it equal. Do the same with the y's. Y squared plus 4y. Half of 4 is 2. Square 2, you get 4. Whatever you add on the left, you have to add on the right. Now, assuming you did everything correctly, this is a perfect square, so factor it. X plus, and the trick is, take half of the linear term, and that's your factor. Half of 6 is 3, so this is x plus 3 squared. For the y's, y plus, half of 4 is 2, so it's y plus 2 squared. Equals, 9 plus 4 is 13, 13 minus 2 is 11. Now we can see that's a circle in center radius form, and we can see my center is equal to, remember to switch your signs, -3, -2. And then my radius is equal to the square root of that side. And that's it. And then if I wanted to, I could graph my circle. We're not going to bother with this. Mostly we care about finding the center and finding the radius. We're going to do one more, just to make sure this is all clear, and then we'll be good. So, suppose I have this one. X squared plus y squared minus 4x plus 10y minus 3 equals 0. I want to put that in center radius form, so reorganize everything, group the x's and the y's together. So I'm going to have x squared minus 4x plus y squared plus 10y. The constant we send to the other side, so that's equal to 3. Now I have the quadratic and linear terms together for the x's and the y's. The leading coefficients of the quadratic terms is 1, so we're good. Now do the whole completing the square trick. So, first figure out what to add. Half of -4 is 2, sign doesn't matter. And then square that. 2 squared is 4, so add 4. Whatever we add on the left, we add on the right. Do the same with the y's. Y squared plus 10y. Half of 10 is 5. 5 squared is 25. But again, whatever we add on the left, we add on the right. Now factor and simplify everything. Here should be a perfect square. Half of -4 is -2, so it's x minus 2 squared. Here should be a perfect square. Half of 10 is 5, so it's y plus 5 squared. Equals 3 plus 4 is 7, 7 plus 25 is 32. And now again we can see we have a circle. The center is at the point +2, -5. Remember to flip your signs. And the radius is equal to the square root of 32. The biggest mistake that people generally make with this is to get this constant and then square it because they remember the formula has an r squared in it. Don't do that. This is the radius squared as it is. Square root it to find your radius. Don't square it, square root it. That should be everything we need. You're going to do several of these for homework, both putting them in center radius form and graphing them. When it comes to graphing them, like I said, find the center, and then just use the radius to go up, down, left, and right, and you can sketch a rough sketch of your circle. And then we'll probably look at some applications in your homework. If you have any questions, feel free to let me know.